Hello, my name is Jwaad Hussain, and this is a 4 degree of freedom robot arm made using the Robotics module of Labview. As you can see here is a 3D scene which shows the robot arm itself, and over here on the right of the scene you can see two tabs. The first tab on the left is the automated control tab, and this would allow you to see how the robot arm would act to pick up an object, place it on a shelf, or 3 different shelves of varying heights. So first we'll pick up the object. I'll first turn the speed down so it's easier to see. We'll pick up the object and then return to home. Then we'll click on shelf 1, and this will lift the object to in front of the shelf, place it into the shelf, return back, and then return back to home. And the same is true for shelf 2 and shelf 3. Changing the movement speed will just allow the robot arm to move a little bit faster by having it make less steps to do the same movement. In my second tab I have manual control, and this would allow you to move the robot arm either in the positive Z or negative Z, or in positive and negative X. Y is disabled because we don't want our robot to be spinning in this direction or this direction. We just want it to go down and up, or left and right. So this is also controlled by the same movement speed tab. So if I wanted to move X and Y a lot faster, I can change my speed up. Also, this is locked to specific X, Y, and Z, X and Z movements. See, I can't move any further left, and that's to stop the robot's joints locking up and giving you an error. This also has the function to return to home. Now we'll look at the block diagram. So, to start the block diagram, I have configured my DH parameters. So I've set my twist angles. Only the first one has been changed. This is to have my initial joint be in the right configuration, so it's upwards rather than parallel to the rest of the joints, so that I can move along the Y. And then the lengths of the arms are set here, and all the joints are set to revolute. Next, we use these DH parameters to configure our robot arm, and for the sake of the simulation we ignore properties of the robot like weight and mass and gravity and friction. Then we give the robot a default joint angle. This is one that the robot's actually able to be in. If I was to give this 0, 0, 0, 0, the robot would be locked up and give me an error. So this is, as you can see by the simulation, a position that the robot can start in. So then next we use the forward kinematic block, and this is so that the previous angle, the current angle that came out, is converted to our X, Y, and Z for the sake of working from current position. So before we look into that more, we'll talk about how we manage automated control. So our current position from the last run will be fed into the forward kinematic, which will give us our X, Y, and Z positions, converted from our transform matrix. That is then extracted to give me just X and Z. So the first object in the array, the first element in the array, and the third element in the array. So those are fed into the default position, which would allow you to have the same X and Z. So we would send the current position. So we would say move to the current position, so the robot would just do nothing. So to actually do a movement, what we would do is we would click our boolean on the front panel. So for instance, we click home, then that would allow us to do this set of movements. So the robot's fed coordinates in X, Y, Z, which are sent as an array. So for the sake of home, it moves from wherever you are to home. But if I wanted to do a movement with more steps, I would send points to move to. So for instance, with the shelf 1, I would send it my current position. No, it would move from the current position to the shelf 1 offset, which is the area before the shelf. Then it moves into the shelf, then it moves back out of the shelf, and then to home. So this is all sent in an array, and is sent to our generate Cartesian trajectory. So this then creates a trajectory for the robot arm to follow. And because this is on auto indexing, it first does it for the first block. So we do it for the first joint. It creates from current position to that block, and then those trajectory points are fed into the inverse kinematics. So each point of that trajectory is fed in one at a time. So the first point, and then is moved to using inverse kinematics. Then the next point of the same trajectory, and then once one loop of that is completed, it moves on to the next point, and works like that as follows. So that's the reason for these shift registers, where these two loops keep looping into each other until the entirety of these 4 points are done. So we need the shift register to keep updating the position. Also, you see here that there's a forward kinematic loop block diagram. There's a forward kinematic block, and this block only serves to convert our joint positions that we get in to a transform matrix. Also here you'll see that we have enabled our X, Y, and Z, and we've disabled rotation. This is because we don't want to allow any movement in X, Y, and Z. And the reason we've enabled Y, even though we're not using Y, is so that we can keep it set to 0, so that it doesn't default to being used to solve at all. And here we have our max step, so this is the amount of times this solver will run before it gives up. So then we feed the output of that into our update plot, and then that allows us to view the robot arm. Now for manual control, we have 5 buttons for manual control on the front panel. And as you can see here, so if I want to change my X, this is my X input. It comes from having broken down my transform output. So my joint inputs come in from here. They're converted to X, Y, and Z. They're converted into a transform matrix. Then that transform matrix is converted to X, Y, and Z. Then I take out only X and Z. So my X is optionally added to. So it goes through here where 0.01 is added to it, and if left is being held down, that 0.01 that's added is taken as truth. But if left isn't being held, then it just takes the previous X. So the same is true for right. So it first checks for left. If left isn't being held, it does nothing, and then it checks for right. If right isn't being held, it does nothing, and then it goes through thresholding. So if I see that my X is already too high, I won't add to it, because then it will lock up the joints. So here it will say if X is above 0.65, then send in the previous X, don't send in the new X. And then it says the same thing but for the lower threshold. If X is below 0.15, send in nothing, send in the previous X. As you can see from this line here, previous X is being sent through. Then lastly, it goes through a check for if the home button is being pressed. So after all those checks, it will check for home. So after all thresholding and all the checks, it checks if home is being pressed. If home is being pressed, then instead of everything else, instead of the new X's and Y's, a single digit for X and a single digit for Z are sent through instead. And the same is true for, same way that I've done X, I've done Z. Then those X, Y, and Z are sent through a transform to translation, so it converts my X, Y, and Z into a transform sent as an array. The reason this has to be sent as an array is because this node is auto-indexing, which means that it will try and index. So if this wasn't an array, it would give me an error. It has to be able to index, but because this is a array of dimension 1, it only plays this once. That's it for my demonstration of my robotic arm simulator. Thanks for watching.